Okay, hi. We're going to talk about 27.12, chapter 27 of University Physics. A horizontal rectangular surface of dimensions 2.8 by 3.2 centimeters and is in a uniform magnetic field that is directed at an angle of 30 degrees above the horizontal. What must the magnitude of the magnetic field be in order to produce a flux of 4.2 times negative 4? So, let's have it here. Okay, we'd like to talk about B because we're talking about the magnetic field, right? We are referring to that. And B is our magnetic field. We want the magnitude of that. So, what is B? So we get it from these equations. BB equals BA cosine phi. Right? We want to have B. So transpose. Phi is 60. Remember our first rule here. So we transpose. We're gonna have phi B over A cosine phi. Let me just show you real quick how that happened. So basically, just from these points, we want to have these only. So it's just like that. A cosine phi, and then the same thing like A cosine phi as well. So cancel. So yeah, cancel. So it's gonna be B equals phi B over A cosine phi. Let's check if we're alright. We're alright. So the phi B here is basically 4.2 times negative 4. Why is it like that? We're talking about the flux here. Flux is the phi or phi. Cannot sure how pronunciation is, but it's alright. A here is the area. Do you remember 2.8 by 3.2? These things are in centimeter. We like it to be meters because we like to be standard basis. So move it dozen places. Cosine 60. So the answer is 0.938. Okay. Next one is the 27.25. An electron in the beam. Oh, we have constants here. You gotta be memorizing some constant here. So 27.25, an electron in the beam of a TV picture tube is accelerated by a potential difference of 2.00 kilovolts. Then it passes through a region of transverse magnetic field, where it moves in a circular arc with radius 0.180 meters. What is the magnitude of the field? So we know, right, when you're talking about electrons are always negative, and yeah, we have here potential difference, we have the radius. So what is the magnitude of the field? Here, when we're talking about constant, always remember that Q is equal to 1.6 times 10 negative 19 coulomb. Q is a charge, make it coulomb. And that is it. We're talking about electron right now, so put a negative there. So it'll be negative 1.60 yada yada. Next, we'd like to know, okay, so when a particular charge, negative E, is accelerated for a potential difference of V, it gains the kinetic energy, right? So when it moves in a circular path of our radius r, what is our r again? Yes, 0.180 meters. That is perfect. So when it moves in that path where radius r, its acceleration is v squared over r. Okay. So remember the constants. Let me write the constants real quick. Okay, just a minute. So the constant we have here is Q equals, well, we're talking about negative because we are referring to electrons. So constant is what you call this one. What is negative? Negative 1.60 times 10 negative 19. wrong position, times 10 negative 19. Okay, and we have here the mass. Okay, I hope you see that. And we have here next is the mass. Is also constant. So it is 9.11 times 1031 negative 31 kilograms. Okay, kilograms. Now, first we'd like to have the these equations. mv squared equals EV. Let's try. Let's see this one. Oh, there you go. This is negative. Electrons are always negative. So 1/2 mv squared equals EV. We need the V. We're not talking about these kind of V. We're talking about these V. So V equals square root, because you have this squared there, 2EV over M. So what is it? What is the either? We're talking about this one. So it's negative 1.6 times 10 negative 19. There you go. Times the V, which is this one, 2.00 kilovolts. So it'll be times 10, 3 over, yeah, so it's over, yeah, this, what is that? It's part 9.11 times 10 negative 3, the mass, yeah, 9.11 times 10 negative 31 rather, kilograms. Okay, so when you calculate that, the 2.65 times 10 7, and we have another formula that we should practice working on. So when we have these 2.65 times 10 to the 7th, we'd like to use this formula. Okay. A moment, please. We'd like to use a formula of, okay, we'd like to use a formula of Q. Now, just a minute, let me start from the other side. We have mv squared over r equals, okay, we're talking about the absolute value of v, of q rather, b sine theta, no, not theta, sine phi. Okay, so qvb sine phi. Okay, and given that the phi is 90 degrees, 90, okay, given phi is 90 degrees, we can say, because remember we're talking about the b, we want the b. Through evaluation, look at these, okay, write it on your paper, please, okay, and transposing derivation, we can say that the b is equal to mv over q r. Okay, and we know the m, let me check, I'm doing it correctly, there you go. And doing that, we have the m 9.11 times 10 negative 31, we have the v squared, yeah, we're talking about the v that we calculated before, so v squared is 2.65 times 10 7, but you have to square it. Do you have to square it? No, don't. Well, no, you don't have to square it, sorry. So, because we have it, oh, sorry, yeah, no squaring, please, no squaring, mv over qr only. M, this is v, and the q is 1.6, this is from that, and the r, right? It's the r, so it's radius, 0.180 meters. Calculating everything, we're going to have 8.38 times 10 negative 4, and that will be our magnitude of the field. So that is a magnitude. So yeah, its magnitude. So the next one, okay, now our last one is an electron moves at 2.5 times 10 to the 6th, 7.4 times 10 negative 2, that's the magnitude. And the first question is what are the largest and smallest particle magnitudes? And let it be if the actual acceleration is 1/4 of the largest in part A, what is the angle? So we can use here the Newton's second law, which is F equals ma, and also our this equation. F equals QVB sine theta, the one that we actually used before. So equating both, we can have A equals QVB over M. The A and the M, you can see that they are from the F equals ma, which is why I have acceleration, because we are being asked to find acceleration. So the Q here is 1.6 times 10 negative 19. It's a column, yeah, it is a constant. The V here is exactly, the V is the velocity, 2.5 times 10 6 to the 6th. And the B here is, where is the B? 9.4 times, sorry, 7.4 times negative 2. That's supposed to be 7. I hope you can see that. Over the M, which is also constant, is in kilogram, 9.11 times 10 negative 31. So, calculating it with your calculator. So, we have the 3.25 times 10 to the 16th. M over S squared has to be squared here. Right, okay. And let B, the actual acceleration is just 1/4. So, we have here 3.25, there's one here. Put it here and look for the 1/4 there. Okay, if the actual acceleration is just 1/4, what is the angle between the electron velocity and the magnetic field? Well, actually, when we're talking about angle, we had the pleasure to talk about the QVB sine theta. So it has a theta, we can make use of that. Right? So equating, and you want to know the theta. So of course, when you have theta, it's supposed to be theta here. Okay, when you have the theta, so when you have the sine theta, you can have the arc sine. So you can have the answer, which is 14.5 degrees. So it's the kind of thing that. Okay, so that's the end of chapter 27. I hope you like it. If you need to pause the video to make sure that you're really following, and if you have any questions, just email me. And yeah, that's it. Bye.